Good morning, sir.
Good morning. Right. So this is the last class. In this class, the pending part I am going to complete. This electrostatics problems, yesterday I didn't keep. That's why I have stopped the class earlier. Now, these are the problems which are based on the capacitance. So whenever we take the two plates of the parallel plate capacitor, these are the two plates of the capacitor. Let us suppose these are the two plates. In between the plates, if air is the medium, then the force between that plates, F is equal to F force that capacitance. Then capacitance C air is equal to epsilon naught A divided by D. What is epsilon naught? Epsilon naught is permittivity. D is the distance between the plates. A is the area of each plate. Then, whenever we take that in a medium of dielectric constant K, permittivity epsilon naught A divided by D. There we'll write C medium is equal to epsilon naught A divided by D. So C medium is equal to K into epsilon naught A divided by D will be equal to C medium. C air. Epsilon naught A divided by D will be equal to capacitance of the capacitor when air is the medium between them. So if you want dielectric constant K is equal to C medium divided by C air, we will write C medium divided by C air. This I have taken, right? So one more I have explained yesterday in the class. So n identical plates are there, alternative plates if they are connected, then number of the capacitors. This is also repeated problem. These are 3 plates. So number of capacitors, we had to say that. First plate, second plate, third plate, fourth plate, fifth, sixth, seventh. These many plates are there. How many capacitors are available? C1, C1, C2, C4, C5, C6. Plates are 7. Number of possible capacitors are 6. 1, 2, 3, 4, 5, 6, 6. So then capacitance of that capacitor N C dash is equal to N minus 1 into C. N identical plates are connected. N identical plates are connected like that. The effective capacitance of the combination C dash is equal to N minus 1 into C. C dash is equal to N minus 1 into C. C dash is equal to N minus 1 into C. These are right. Now we'll see that the capacity of a parallel plate condenser is 5 microfarads. Capacity is given 5 microfarads. 5 microfarads. When the glass is placed between the plates of the condenser, the potential becomes 1 by 8 times. Potential. Now initial potential is taken as a V. V is taken as a V. So C1 is taken as V and C. Next case, when the glass plate is placed, then new potential is taken as 1 by 8 times the actual potential. 1 by 8 times the actual potential. Then the value of the dielectric constant he has asked. Then what is the value of the dielectric constant? What is the value of dielectric constant? So if potential is placed, if the dielectric is placed, then potential decreases. On placing a dielectric, potential decreases. If potential decreases, n times, then its capacitance increases by n times. If n times potential that decreases, then capacitance increases by, then the capacitance increases by n times. There we write. So what is taken? V dash is equal to 1 by 8 times of V. Then now we'll take that V dash is equal to 1 by 8 times of that V. Okay. Then whenever the potential, whenever the dielectric is placed, the potential will become 1 by K times. 1 by K is equal to 1 by 8 V. whenever a dielectric is placed, the potential will be reduced by 1 by 8. So V dash is equal to V by K. V by K is equal to 1 by 8. There V get cancelled. Therefore, K is equal to 8. K is equal to 8. Dielectric constant is taken as 8. Next problem. The energy of a charged capacitor is given by the expression. Energy stored in the capacitor U is equal to half CV square. U is equal to half QV. V is equal to half QV. Or U is equal to half Q square divided by C. These many formulas are there. Then we have to check which is there in the options. Q square by 2C. It is there. Q square by 2C. The option is correct. Q square divided by 2C is correct. Next. The capacitance of the conductor is 4 into 10 power minus 6 farad. Capacitance of the conductor is 4 into 10 power minus 6 farad. And its potential is V is given as 100 volt. The energy released on discharging it fully. Energy released. Same the formulas we have discussed. Energy U is equal to half QV, half CV square, half Q square divided by C. Those are. So then energy stored U is equal to 1 by 2 CV square. Then U is equal to 1 by 2 into C is 4 into 10 power minus 6. V is 100 whole square. 100 whole square. Then we cancel this 2 in 4 2 times. Therefore, U is equal to 2 into 10 power minus 6 into 100 whole square will be equal to 10 power 4. This 10 power 4 gets cancelled. U is equal to 2 into 10 power minus 2. Therefore, U is equal to 0.02 joules. First option is correct. Next. In a charged capacitor, the energy resides. Energy that will be there in between the plates of the capacitor. Energy or charge will be in between the plates of the capacitor. C option is correct. Next. 8 drops of mercury of equal radii possessing equal charges combine to form a big drop. Then the capacitance of the big drop compared to the individual drops. So one big drop of radius capital R is there. Big drop is split into an identical drops. 8 drops. Big drop that split into 8 drops. Three, 7. Like this. Big drop of radius. Radius R. Radius capital R, big one. Its radius is capital R. Then, what is the relation between them? Radius of that big drop and small drop relation they have asked. Radius volume of the big drop is equal to n into volume of the small drops. N into volume of the small drops. So volume of that one is equal to 4 by third pi r cube is equal to n into 4 by third pi into small r cube, right? Now 4 by third pi gets cancelled. There r cube is equal to n into small r cube. N into small r cube. Then r is equal to n power 1 by 3 into r. N power 1 by 3 into r. That is r is equal to n power 1 by 3 into r. This is the formula. Then what did they say? R is equal to n power 1 by 3 into r. Given that 8 drops are gained, n is equal to 8. If we keep that, n is equal to 8. R is equal to 8 whole power 1 by 3 into small r. Then r is equal to 8. We may write 2 whole cube. 2 whole cube whole power 1 by 3 into r. Then this will get cancelled. Therefore, r is equal to 2 into small r. R is equal to 2 into small r. 2 into r. R is equal to 2 into r. 2 times. This is 2 times. 8 drops of mercury of equal radii possessing equal charges combined to form a big drop. Then the capacitance of bigger drop compared to each individual small drops is 2 times this. Next. A condenser of capacity 50 microfarads is charged to 10 volts. A condenser of capacity C is equal to 50 microfarads charged to 10 volts. The C is equal to 50 into 10 power minus 6 charged to 10 volts. V is taken as 10 volt. Then energy stored is, we have to take energy storage. U is equal to half CV square. Then U is equal to 1 by 2 into, what is C? C is 50 into 10 power minus 6 into 10. It will get cancelled 25 times.
So 10 square then.
10 square. Then 25 into 10 power minus 6 into 100. 100 it is. So this will be 10 power minus 4. U is equal to 25 into 10 power minus 4. Otherwise, U is equal to 2.5 into 10 power minus 3 joules. A option is correct. Next. A parallel plate condenser has capacitance 50 microfarads in air and 110 microfarads when immersed in the oil. The dielectric constant of that. It is given a parallel plate condenser has capacitance. Capacitance whenever the air is the medium between the plates. C air is equal to 50 into 10 power minus 6 farads. Otherwise, 50 microfarads we can keep. 50 microfarads. Then whenever it is placed in a medium, it's oil. Oil is nothing but medium between that. Medium. That will be 110 microfarads. 110 microfarads. There I have given that C medium is equal to K into C air. Therefore, dielectric constant K is equal to capacitance of the capacitor when a medium is between them, when divided by air. Then K is equal to C medium 110 divided by C air 50. 50. 0, 0 gets cancelled. K is equal to 1 divided by 5. Therefore, K is equal to nearly 11. 2.2, nearly 2.2. This is correct. 2.2. Right. This is whenever we take, when plates, that separation between the plates of parallel plate capacitor is D, and the area of each plate is A, then the slab of dielectric constant of thickness T is introduced between the plates, its capacitance. When a dielectric is placed between the plates of dielectric constant K, whose thickness is taken as T, whose thickness is taken as T. A dielectric of dielectric constant whose thickness is T is placed. K is the dielectric constant whose thickness is taken as T. Distance between the plates is taken as D. Potential is V. Area of each plate is A. There we will write capacitance of this capacitor C is equal to epsilon naught A divided by T minus D minus T into 1 minus 1 divided by K. This is the part. C is equal to epsilon naught A divided by D minus T into 1 minus 1 by K. In this case, again, we can go for H. If distance is equal to thickness, we write this formula, we can rewrite R C is equal to epsilon naught A divided by D minus T plus T divided by K. If D is equal to T, means what? Dielectric constant is completely if it fits. Completely dielectric constant is fit. D is equal to T, then what have to take? This is D and T will get cancelled. D is equal to T, Dn will get cancelled. C is equal to epsilon naught A divided by T by K. Or we'll write that C is equal to K epsilon naught A divided by T. For us, the required formula is this one only, but just to have modified formula also have shown. Instead of that, distance between the plates is completely filled with the dielectric constant, then we'll take it. Dielectric constant, then we will take it. Right? Next problem. The capacity of a parallel plate condenser depends upon capacity of a parallel plate capacitor depends upon C is equal to epsilon naught A divided by D. Epsilon naught A divided by D. So C is equal to C is proportional to A, or we'll write that C is equal to K epsilon naught A, K for dielectric medium. K epsilon naught A divided by D. So this capacitance of the capacitor depends upon the area. Capacitance is depends upon the dielectric constant. Capacitance of the capacitor is inversely proportional to distance between the plates. We have to check that. What are that? The type of material used, the thickness of the plates, the potential applies the plates, the separation between the plates. So all these are not correct. Last one only the correct one. First three are not correct. Fourth one is correct. The separation between the plates is correct. Separation between the plates is correct. Okay, next. This is the arrangement. Then we have to calculate effective capacitance between the plates. Between A, B, we have to calculate. To simplify this, take these two are in parallel. Take these two are in parallel first, and I'll redraw the diagram. These two are in parallel, and for that this is parallel, and for that it is series. See how I'll redraw the diagram. These are in, what I'm saying that this I will draw in parallel combination. On redrawing this, on redrawing it, let us suppose this is AB. Two microfarads. This I have taken. What are those? These two I have taken. Right. Next, for this down one capacitor is there, 2 microfarad. For this I am attaching. This is 12 microfarads. See how these are. These are in parallel. These are in parallel connection. If they are in parallel, effective capacitance will be, if they are in parallel, effective capacitance will be Cp is equal to C1 plus C2. Therefore, on redrawing this, this is A, and this is 4 microfarads. Down what is there? 2 microfarads is there. Okay, here what is this? 12 microfarads is there. Here it is 12 microfarads. 12 microfarads. Like this. So first these two, they are in series. If they are in series, CS is equal to, what's the formula? CS is equal to C1 C2 divided by C1 plus C2. So C is equal to 4, C1 is equal to 4, 12 divided by 12 plus 4, 16. 4 that cancel in 16 4 times. 4 that cancel in 12 3 times. So 3 microfarads. Okay, and redrawing this A and down 2 microfarads is there. 2 microfarads is there. Then we'll take that this is a 3 microfarads. 2 microfarads and 3 microfarads, so they are in parallel. 2 plus 3 5. 5 microfarad is the answer. 5 microfarad is the answer. Right, next. This is like this. See, just I'll take 5 minutes of break. After 5 minutes, I will start. So I don't shut down it. 5 minutes after I will start the session. Please give me 5 minutes time. Okay, thank you. I'm going to restart the session. See that what is the effective capacitance between A and B in the following circuit? What is the effective capacitance between AB in the following circuit? First two microfarads, they are in series. 2 microfarads and 2 microfarads, they are in series. So the effective combination, effective capacitance of these two, effective capacitance of these two is taken as 2 micro. This is called as the series combination. CS is equal to what? C1, C2 divided by. CS is equal to C1, C2 divided by C1 plus C2. C1 plus C2. Then what is that? CS is equal to C1 plus C2. Then CS is equal to otherwise shortcut formula we may use. What is the shortcut formula for this? CS is equal to C by N. When an identical resistors are there in identical capacitors are there in series, the effective capacitance will be, when an identical capacitors are in series, effective capacitance CS is equal to C divided by N. How many are there? There are C is 2 and there are 2 capacitors. So 2 divided by 2. 2 get cancelled. 1 will be there. 1 microfarad. Effective capacitance on top is how much? 1 microfarad. See this middle, what is there? 1 microfarad is there. 1 microfarad is there. Down, this is A. This is B. Top, how much it is there? This is we got 1 microfarad. 1 microfarad and 1 microfarad, they are in parallel. As they are in parallel, CP is equal to C1 plus C2. CP is equal to 1 plus 1. So CP is equal to 2 microfarads. CP is equal to 2 microfarads. Effective capacitance CAP is equal to 2 microfarads. This is it. Effective capacitance between AB in the figure as shown. Effective capacitance equivalent. We have to take that Weiston's bridge condition. What is that Weiston's bridge condition? C1. This is taken as C1. C2. C3. C4. If C1 by C2 is equal to C3 by C4, then this is, let us suppose C5. This I am naming as a C5. C1 is equal to, C1 by C2 is equal to C3 is C4. C5 would be neglected. C5 would be neglected, right? Then if I neglect this one, what is there? This is A, top one capacitor. Right. This is B. It's taken as C1. C1 is how much? 3. 3, 6, 4, 8. So will it come? C1 by C2 is equal to C3 by C4 will C4 will come? Yes. This is 3. 3 by 6 is equal to 4 by 8. So this is same. How 3 get cancelled 2 times, 4 get cancelled 2 times. 1 by 2 is equal to 1 by 2. Left side 1 by 2, right side also 1 by 2. That will take 1 by 2, 1 by 2 like this. That we have taken. See 3, 6, 4, 8 like that. This we may take. How these are? These are in series. These are in series. Then top. These are in series means C1, C2 by C1 plus C2. So then top one if I take CS1. CS1 is C1, C2 by C1 plus C2. So 3 into 6 divided by 3 plus 6. C1, C2 by C1 plus C2. So 3 into 6 divided by 3 plus 6 is 9. Therefore, it would be 3 get cancelled 9 3 times. It will get cancelled 2 times. So CS1 is equal to 2. CS1 is equal to 2 microfarads. CS1 is equal to 2 microfarads. Like CS2. CS2 is equal 4 into 8. 4 into 8 divided by 4 plus 8. 4 plus 8 will be equal to 12. There, 4 that cancel how many times? 3 times. 8 by 3. CS2 is equal to 8 by 3. Then how these are? Across AB, top, across AB, wish to get one is that CS1 is 2 microfarads. 2 microfarads. And down what is there? It is 8 by 3 microfarads. 8 by 3 microfarads. There, how these are? These are in parallel. Parallel means we have to add them. CAB is equal to 2 plus 8 by 3. So CAB is equal to 2 plus 8 by 3. If I take the 3, so 2, 3 into 2, 6. 6 plus 8, 14. 14 by 3. CAB is equal to 14 divided by 3 microfarads. If you want, I will take this white screen and I'll explain once again. 3 by 4, no, 14 by 3 we got. 14 by 3 microfarads. If we require, I will take the one screen. I mean, if it is confusing, I will take the screen, green screen, I mean, so white screen, and I'll explain. Not required. Okay, we'll go to that next one. See, errors. For example, they'll give this x is equal to a power n m power m. Percentage of error, if you want to calculate, percentage of error, delta x divided by x into 100 is equal to this we have to bring to the numerator, a power n b power m. Minus m will be there, but we'll take plus or minus. Either plus or minus, will take plus only. So plus or minus, this power will write as a coefficient, n into delta a by a into 100 plus this power. Minus m we should not write, plus m only will write that. m into delta b divided by b into 100. Delta b by b into 100. So delta x by x into 100 is equal plus or minus n into delta a by a into 100 plus m into delta b by b into 100. So delta x divided by x into 100 is equal to plus or minus like this. If they give the data, we'll write that. For example, if I take x is equal to a b square divided by c cube. First we have to write x is equal to a b square c power minus 3. Then delta x divided by x is equal to, this will write plus or minus, will write first. So delta a by a into 100 plus 2 into delta b divided by b into 100 plus 3 into delta c by c into 100. This is the calculate percentage of errors. For example, if they give the percentage of errors in percentage of errors in A, B, C are 1%, 2%, and 3%. Then the percentage of errors. So delta x divided by x into 100 is equal to delta a by a into 100. It will be taken as 1%. Plus 2 into delta b by b into 100 is 2%. Plus 3 into delta c by c into 100. It is taken as 3%. Like this. So delta x divided by x into 100 is equal to 1%. Plus 2 into 2, 4%. Plus 3 3s are 9%. So delta x by x into 100 is equal to 1%, 4 plus 9, 14%. 14%. Total 14% we will get. Like this, we will simplify. Important repeated problems are there. Next, this is like this. How to take that? Delta x by x is equal to n in delta a by a plus m in delta b by b. If you take x is equal to a by b, delta x by x is equal to plus or minus 1 into delta a by a plus 1 in delta b by b. These are taken when two resistors are connected in series. Rs is equal to delta Rs is equal to R1 plus R2. Delta Rs is equal to delta R1 plus delta R2. Therefore, delta Rs by Rs is equal to delta R1 plus delta R2. This is series combination. Parallel combination will be like this. 1 by Rp is equal to 1 by R1 plus 1 by R2. Then delta Rp by Rp square is equal to delta R1 divided by R1 square plus delta R2 divided by R2 square. This is delta Rp divided by Rp square is equal to delta R1 divided by R1 square plus delta R2 divided by R2 square, like this. Significant figures. Most reliable value plus one more digit is to be added, approximated for its accuracy is called as significant figure. For example, I want to measure, this is an object, its length I want to measure. Whenever I compare with that scale, if I compare with the scale, it used to show 2.5 and 2.6. in between 2.5 and 2.6 it shows. In between 2.5 and 2.6 it will show. Maybe 2.53, 2.54, 2.56 like that it will be there. So up to 2.5 well-known digit. 2.5 is fixed, confirm, it is well known. And afterwards to say it's a measurement exactly 2.53 or 2.54 like that, that last digit I am adding, that is called as the significant figure. Most reliable value plus one more digit is to be approximated is called as the significant figure, right? Significant figure while you are writing 0.0023 is there. How many significant figures are there in it? If the zeros are below that or before the non-zeros, they are not counted. If the zeros are before the non-zeros, they are not counted. So number of significant figures are 2. We'll take that. Number of significant figures are 2. Right? There are number of significant figures 2. We will take it. If I take 0.203, as 0 is there in between the non-zeros, all 1, 2, 3, it is counted. Number of significant figures will be 3. As 0 is in between the non-zeros, it's the number of significant figures that are taken. 2, 0, 3. 3. All the 3 are considered. If we take that 2.2004, number of significant figures 1, 2, 3, 4, 5. Total number of significant figures are 5. Like this we'll take. Or if I take that 23.450, this 0 is the right side of the non-zeros, then it is valid. It is counted. Number of significant figures 1, 2, 3, 4, 5. Total 5 significant figures. If the 0 is right side of the non-zeros, it is counted. 0 is between the non-zeros also counted. If 0 is before the non-zeros, then it won't be counted. This is significant figure. This is called as the significant figure, right? Significant figures. Next, if 2 into 10 power 4 is there, number of significant figures in it. 10 power 4 is not counted. 10 power 4 is not counted. Only 2 we consider. Number of significant figures in it is taken as only 1. Number of significant figures in it is taken as only 1. Right? See, first one. All non-zero digits are significant. 42.30. 42.3 has 3 significant figures. 243.4 has 4 significant figures. 24.123 has 5 significant figures. All non-zeros are significant. It is a 0 between it becomes significant figure if it appears between the non-zeros. 5.03 has 3 significant figures. 5.604 has 4 significant figures. 4.004 4 significant figures. Like next, leading zeros are the zeros placed to the left of the number are never significant. 0.534 543 0.543. So 1, 2, 3 3 significant figures are there. 0.045 only 2 significant figures. 0.006 has only 1 significant figure. These zeros are before that. These are before it. That's why 6 has only 1 significant figure. Only 1 significant figure. How many are there in it? 2 significant figures are there. How many are there? 3 significant figures are 3, 2, like that. They'll be there. Next. Trailing zeros are the zeros placed to the right side are significant. Say 4.330 significant. All 4 are significant figures. 433.00 has 5 significant figures. 343.000 has 6 significant figures. All of them are 6 significant figures. These are okay. In exponential notation, the numerical portion gives that number of significant figures. In exponential notation, The numerical portion gives that number of significant figures. See, 1.32 into 10 power minus 2 is there. This 1.32 only 3 significant figures adds. 10 power plus minus 2 is not counted. 1.32 and 10 power plus 4 is there. It has 3 significant figures. 10 power plus 4 is not counted. Like that we will take. This is regarding the significant figures. Next one is rounding off a number. Rounding off a number. First two rules we know that. Let us suppose the dropped digit is less than 5, then the preceding digit does not change. For example, 23.43 is there. I have to round off it for the 3 significant figures, means 3 numbers only I want. So 3 I am going to drop it. While dropping, as 3 is less than 5, as 3 is less than 5, it won't be counted. 3.4 only. That 23.4 only correct. So 23.4 only correct. Okay. Then if I take if I drop this 249.74, I'm going to drop up to 4. Whenever I drop the 4, then there is no change in the preceding digit. That will be 249.7 only. 249.7 only it is. Next, first one. Second one is, if the drop digit is greater than 5, then the preceding digit will be raised by 1. 48.37 is there. I am going to drop up to that 7. I am going to drop up to 7. 7 is greater than 5. That's why preceding digit will be raised by 1. It will be 48.43. It's a rounding of that. This you know. The third one is important. If the digit dropped is is 5 followed by a number other than 0. If it is 0, different concept. So this is other than 5 we are going to draw. 63.751 63.751. We are going to drop up to 5. 5 is followed by a number. 5 is followed by a number. Then 63.7. We are going to drop up to 5. Then 63.7. This is we are going to drop up to the 5. 5 is followed by a number. Maybe whatever may be 1, 2, 3, 4, whatever may be the number. Then it becomes as 63.7. This becomes as 63.8. Like this. One moment. I'm muting. Okay, like this will take. If the digit is to be dropped, right? So if the digit is to be dropped, if the digit to be dropped, 5, and 5 is followed by a number, maybe 1, 2, 3, 4, 5, 6, whatever it may be, then the preceding digit will be raised by 1. Then 7 is there, 7 becomes 8. If 8 is there, 8 becomes 9, like that. So the preceding digit will be raised by 1. Next, if the digit dropped is if the digit to be dropped, digit dropped is if the digit dropped is 5 followed by 0. Followed by 0. Digit dropped is 5, which is followed by 0. Right? Then it is dropped. It is followed by 0. If the digit dropped is 5 followed by 0. In that, two cases. First, if there is no change, in the preceding digit, if there is no change in the preceding digit, if it is even, but even. Next one, the preceding digit will be raised by 1 if the preceding digit will be raised 1 if it is odd. If it is odd, like if it is odd, the preceding digit will be raised by 1. So we'll take that. See, first one I am taking that 78.450. I am going to drop up to 5 followed by 0. Then preceding digit is a even number. That's why there is no change in it. 78.4. It will be 78.4 only will come. Next, if I take that for the B, I am taking example 86.350 is there. I am going to drop up to 5. I am going to drop up to 5, and it is followed by 0. Then as the preceding digit is odd, it will be raised by 1. 86.4, like this. These are the rules. Typed one is there. I am going to show you. If the digit to be dropped is less than 5, then the preceding digit is left unchanged. Digit is dropped less than 5, then there is no change. 7.82 is rounded off for 7.8. 7.82 is rounded off for 7.8. Again, 3.94 is rounded off to 3.9. 3.94 is there. 4 is less than 5. That's why 3.9 only. Next, if the digit to be dropped is more than 5, then the preceding digit raised by 1. 6.87 is there. 7 is greater than 5. That's why it will be raised by 1. This 8 becomes as 9. See that? 6.9 it is. Again, 12.78 is there. We are going to drop up to 8. 8 is greater than 5. That's why this 7 becomes 8. 12.8 we will get. 12.8. Next. If the digit to be dropped is 5 followed by digits other than 0, then the preceding digit raised by 1. If a digit is dropped 5, which is followed by any number, maybe 1, 2, 3, 4, it's none of the matter. Then the preceding digit, if it is even, there is no change. If it is odd, it will be raised by 1. Preceding digit dropped is 5, followed. If you are going to drop up to 5, 5 is followed by any number other than 0. Then always there will be a rise of 1 for the preceding digit. Say 16.351 is there. I am going to drop up to 51. Then the preceding digit, it will be raised by 3 becomes as 4, 16.4. 6.758 is there. I am going to drop up to the 5. Then it is followed by 6.7. 6.7 becomes as 6.8, like this. The last one. Next one. If the digit is to be dropped 5, which is followed by zeros, then if it is preceding digit is even, there is no change. See, 3.520 is there. Preceding digit is a even number. That's why there is no change. 3.2. 3.2. So again, 12.650 is there. So this 12.650, this is up to 50. We are going to drop. So 12.6 on rounding off. Right. If the digit is dropped is 5 followed by zeros, then the preceding digit is raised by 1 if it is odd. 3.750 is there. 7 is odd number. 7 becomes 8. So 3.8 it is. So 6.150. 1 becomes as 2. We are dropping up to that 5. So 1 is considered as a odd number only. Then 1 becomes as 2. Like this. Errors we have discussed. Right. We'll see that numericals. It is that the unit of the physical quantity which has dimensions of, which has 1 dimensions of mass, minus 1 dimensions of length, minus 2 dimensions of time. These are repeated problems. So then dimensional formula you have to get like this. That they told dimensional formula should be like this. M1 L power minus 1 T power minus 2. This is. We'll check that one by one. We'll check it. First one, volt. Volt. Volt unit is what? Volt is called potential. Potential is equal to work done by charge. Work done divided by charge. M1 L2 T power minus 2 divided by charge Q is equal to I into T. IT. This comes to M1 L2 T power minus 3 I power minus 1. This is volt. So this is wrong. This is not correct. Second one is Pascal. Pascal is the unit of the pressure. Pressure is equal to force per unit area. Force, so M1 L1 T power minus 2 divided by area L square. 1 L get cancelled. This L, if it comes to numerator, that will take M1 L power minus 1 T power minus 2. So this is correct. Means Pascal is the correct answer. Pascal is the correct answer. Right? Next. See, we have to show E, M, L, and G denote energy, mass, angular momentum, and gravitational constant respectively. The dimensions of E L square, M power 5, and G5. E for E is given as energy, mass, L for angular momentum, M is mass, G is universal gravitational constant. Angular momentum dimensional formula, first we'll take that. L for angular momentum. L is equal to MVR. This is kg meter per second and meter. kg meter square per second. Kg meter square per second. That will take. Then some x is taken as EL square. EL square divided by m power 5 g square. Dimensional formulas. We'll write that E m1 L2 t power minus 2 m1 L2 t power minus 1 divided by m power 5 g universal gravitational constant g m power minus 1 m power minus 1 m power minus 1 m power minus 1 g is equal to fr square divided by kg square. Kg meter per second square per kg per meter square. Okay. Per kg per meter cube. Kg m3 L m1 L3 t power minus 2 whole square it is. This is the universal gravitational constant. Then x is equal to m power 1 m power 2 L power 4 t power minus 3 in the numerator. M power 5. This is m power minus 2 L power 6 t power 4. This is n power 2 m power 2. One more m is there. M power minus 2 m power 2 power 5. One more m is there. M power 5 it is 5 4 m1 L2 t power minus 2 L square is there. So angular momentum formula L is equal to m1 L2 t power minus 1. This L square is there. That's why as L square is there, that's why you have to write here m power 2 L power 4 and t power minus 2. M power 2 L power 4 t power minus 2. Then x is equal to m power 1 no m power 2. This is equal to m power 3 L power 6 t power minus 4 divided by m power 5 m power 5, then m whole square it is m power 5, then m power minus 2 L power 2 3s are 6 t power minus 4. We have to simplify it. See m power 3 m power 3 gets cancelled. These two get cancelled. L power 6 L power 6 t power 4 t power 4 all they get cancelled. What is the dimensional formula? Will get m0 L0 t0. It is for the angle. m0 t0 m0 L0 t0. It's for angle. It is for the angle. It's for the angle. It's for the angle. Next. Like this, we'll solve the numericals. Yesterday, I have started these logic gates. I will explain the logic gates and I'll stop the class. Only logic gates I will explain and I'll stop the class. Please give me 5 minutes time. That's sufficient, or less than 5 minutes only. Logic gates. How many are there? Total 6 logic gates. I will say that. One is that OR gate. One is OR gate. Second one is AND gate. Third one is NOT gate. Fourth one is not OR gate, called as the NOR gate. Fifth one is not AND gate, called as the NAND gate. Sixth one is XOR gate. Seventh one is XNOR gate. XOR gate and XNOR gate. That is, these are gates. Then OR gate operation is addition. This OR gate operation is nothing but addition. Please wait only 5 minutes or less than 5 minutes. I will take and complete the class. OR gate. OR gate operation is nothing but addition. This is the symbol for the OR gate. Let us suppose A and B are the inputs. A and B are the inputs. Then output will be Y is equal to A plus B. If you take that truth table, if you take that truth table, A, B, Y is equal to A plus B. Y is equal to A plus B. Where A is 0, B is 0, Y is equal to 0. A is 1, B is 0, Y will be 1. A 0, B 1 is 1. And A1, B1, output will be 1. This is the truth table for the OR gate. Next, AND gate. AND gate. AND gate operation is multiplication. A and B are inputs. A and B are inputs. Output will be Y is equal to A into B. Y is equal to A into B. Truth table will take that. Truth table will take that. A, B, Y is equal to A into B. If I take 0, 0. 0 into 0, 0 only. 1 into 0, 0 only. 0 into 1, 0 only. 0. 1 into 1, 1. Like this. This is the truth table for the AND gate. Next, NOT gate. NOT gate. NOT gate operation is NOT gate operation is. So 1 is the input, A is the input, A is the input, its complement. Output will be its complement. 0, it becomes 1. 1, it becomes as 0. This is the NOT gate. NOT gate we can attach to that OR gate called as a NOR gate. NOT gate we can attach to the AND gate called as the NAND gate. Then this will be quite opposite. For its complement we will get it. 1 becomes 0, 0 becomes 1 for this NAND gate. First we'll take that NOR gate. NOR gate. Not OR gate it is. A and B inputs. Output Y is equal to A plus B complement. Then truth table, if I take A, B inputs, output will be A plus B complement. A0, B0, output will be 0 plus 0, 0, but its output 1. 1, 0. This is 0. 0, 1. It will be 0. 1, 1, 0. This is output. Next. NAND gate, not AND gate. Not AND gate is called as the NAND gate. For AND gate, if you add the NOT gate, it will form NAND gate. A and B, then output will be Y is equal to A into B complement. Then A, B, Y is equal to A into B complement. A into B complement. A0, B0. Output will be 0, but 1 will come. A0, A1, B0. Output will be 0, but 1 will come. 0, 1. It will output be 0, 1 will come. Then 1 and 1. 1, 1, 1, 1 for that AND gate, it will be 1. But here complement it is taken as 0. Right. Last two gates. XOR gate. Exclusive OR gate will say that. XOR gate means what? Exclusive OR gate. The gate will be like this. Exclusive OR gate it is. This is called as exclusive OR gate. Y is equal to exclusive OR gate. Y is equal to A complement into B plus A into B complement. A into B complement. So truth table will take that. A, B are inputs. Output will be equal to A complement into B plus A into B complement. 8, 0, 0. Output will be 0. 1, 0, 1. 0, 1. It will be 1. 1 and 1. 1 and 1. It will be 0. Like this. Next are XOR gate, XNOR gate. Exclusive NOR gate. This is X or XNOR. Y is equal to A complement into B complement plus A into B. A into B. Then truth table. This is the last. Truth table, if I take A, B, output will be A complement into B complement plus A into B. Therefore, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1 and 1. No, this is 0. 0. 1 and 1. 1. This is the truth table. Up here, our syllabus is completed. Then I'm going to stop the class here. Thank you.